So in the last lecture, we were dealing with the numericals, so for the second chapter. So we will continue the same for today also. So now the next numerical is find out moment of force. Find out moment of all the forces acting at point B about A. Full stop. Also find out the resultant force. So the diagram I will draw now. So this is the surface. The force is given in this way. And this force is of 200 Newton. This angle is 20 degree. Here it is point A. And here somewhere there is point B. And it is like this. The distance between these two, it is given as 500 mm. It is given as 500 mm. So find out the moment of all forces about point B, at point B about A. About A. Also find out the resultant force. So you have to find out the resultant force also, and you have to tell what is the moment of force about point A. So how we are going to solve this? So in this numerical, they told you to find out the resultant force. It means that they have not given you the system is in equilibrium. Okay, you should distinguish between the problems. Okay, it is the problem which may be asked in the first chapter. Likewise, that type of problem is there. They ask you to find out resultant force. They do not tell you that the system is in equilibrium. If the system is in equilibrium, then summation fx0, fy0 and movement 0. If the system is in equilibrium, then resultant force is 0. Here they have not mentioned that system is in equilibrium, and contradictorily they told us to find out the resultant force. Okay, so now how to solve this numerical? Okay, by seeing the diagram, can you tell me what will be the moment of force about point A? Anybody? So if you see this force of 200 Newton, if you see it is passing through point A. It is passing through point A. So its movement about point A must be zero. Its movement about point A must be zero because that force is passing through that point. Okay. Even though if you resolve this and if you take the moment, you will get the same answer. You will get the answer as zero. Okay. You will get the answer as zero. That is your homework. You resolve this force and then also calculate the moment at point A. You will get the same answer. So now the next point is find out the resultant force. So to find out the resultant force, what I will do, I will resolve this force into two components. One is parallel to y, another is parallel to x. So these are our two components. Then if this angle is 20 degree, then this angle must be 20 degree. These two are the corresponding angles. So this will become 200 sine 20 and this will become 200 cos 20. Cos 20. So now if you calculate the resultant force, so how to calculate that? Calculate summation fx first. So if I calculate summation fx, then summation fx is equal to 200 cos of 20, which is equal to, what is the answer of summation fx?
One 187.93.
187.93. 187.93. Okay, so this is your summation fx. Now calculate summation fy. Summation fy is equal to, it is 200 sine of 20 degree. So how much?
68.40.
It is 68.40 Newton. Now resultant R is equal to under root summation fx square plus summation fy square. So just put the values. So therefore R is equal to, put the value
199.99.
199.99 Newton. So this is the resultant. Now calculate the alpha. So tan of alpha is equal to in mod summation fy upon summation fx. So put the values, you will get the value of alpha.
सर मागची स्लाइड ओपन करा. झालं सर कंप्लीट.
So put the values and let me know the answer. This alpha. Calculate this alpha.
Alpha equals to 19.99 degree.
Alpha is equal to 19.99 degree. So this is your answer. This is alpha. And this is your resultant. Okay. So only single force is there. बघा म्हणजे तेवढंच आन्सर तुमचं यायला पाहिजे होतं. आलाय का बघा नियर अबाउट 200 199.99. Angle is 20 degree. It is inclined at 20 degree. You are here getting 199.99. And a single force is there. It is passing through point A. So its moment will be 0. So the next numerical. Circular roller of radius 5 centimeter and weight 100 Newton rests on smooth horizontal surface. Smooth horizontal surface. Remember one thing, in a numerical when the word smooth comes, smooth surface, then your mu is 0. Okay, coefficient of friction becomes 0. Frictional force is 0 there. Okay. So smooth surface is the meaning of that. That is why they have mentioned you the type of surface, smooth surface or rough surface. If rough surface is there, then friction is present over there. If the smooth surface is there, then friction is absent over there. Surface and is held in position by inclined bar AB of length 10 centimeter as shown in figure. Full stop. Horizontal force of 200 Newton is acting at B. Find the force in bar AB and vertical reaction at C. So the diagram I will draw now. So here is first circular roller. Then it is resting on a smooth surface. This is the surface on which it is resting. Okay. Then what they have told us, radius is 5 centimeter, weight is 100 Newton. Then in the numerical here, point B is given at the center. So this is the central point. It is nothing but your point B. This is point B. This roller is held in position by inclined bar AB of length 10 centimeter. So I will draw this bar. This is the bar AB. It is in this way. This is your point A. And the length of this bar is 10 centimeter. Length of this bar is 10 centimeter. And it is inclined at an angle of 60 degree. So if I draw here horizontal and vertical line, here I will draw these lines. This is the perfectly horizontal line and this is vertical line. So why we draw these lines? So that it will become easier for us to measure the angles. Okay. So here is the contact point where the reaction is there. So vertical reaction, what they have to ask us, the horizontal force of 200 Newton is acting at B. So I will show the horizontal force. So this is the horizontal force which is acting from B. The horizontal force, it is having the magnitude of how much? 200 Newton. This is of 200 Newton. Now further they told us find the force in bar AB and vertical reaction at point C. So I will show the vertical reaction at point C, and that reaction will be, this is the point C and here is the vertical reaction. We are assuming that the vertical reaction is upward. Okay, so this is point C. And I will call this as VC, vertical reaction at point C. Initially, we don't know whether this vertical reaction that VC is moving upward or downward. Okay, we don't know anything right now. So we have assumed that it is moving upward. If we get positive answer, then our direction is correct. If we get negative answer of VC, then we can say that it is moving in downward direction. We have also seen that type of problem in previous lectures. And also with this angle with vertical, this angle it is given as 60 degree, or you can find out this angle why it is to be given. Okay. So this is the thing which is given to you. Now we need to find out the force in bar AB and vertical reaction VC. Now how to find out this? Think on this. I will tell you that this bar AB, so that circular roller should not move forward. To resist that motion, this bar is tight. Okay, the bar tight केलेला आहे. So the force in bar will be like this. I am showing the arrow away from this joint. So this is the force in bar, and I will assume this force as, I will give the notation FAB. So force in bar AB, and I have assumed direction in this way. Okay. Normally we assume the tensile force. If we got the negative answer, then also we change the direction over here also. Okay, initially to begin with, we have to take some direction of the forces, otherwise we can't solve. So here FAB force is also we have to find out, VC is also we need to find out. So we have assumed that VC is moving vertical. We get positive answer, well and good, it is vertical. But if we get negative answer, then we can say that, oh, it is moving downward, not upward. Similarly, for bar AB, initially we have assumed that pull is there, pull. Okay, tensile force is there. Okay, So that I have shown over here. But if we get negative answer, then we can say that no, it is not a pull, it is push. It is that type of force. So this is the diagram now. Now we need to find out the force in bar AB and vertical reaction at point C. Okay. So here you can see this length. If I draw here, this length you can see from this point to this point here. This is 5 centimeter. Okay. So this length is 5 centimeter. Then if you measure this bar AB, this bar AB, okay, bar AB. The length of bar AB is how much? It is 10 centimeter. Now if you see this line is vertical, this line is the vertical line. Okay, reaction always makes an angle of 90 degree with the surface through which it is acting. Note down this point. Reaction always makes an angle of 90 degree, okay, to the surface through which it is acting. So now here you can see this is the horizontal is the surface. आणि हा तुम्ही रोलर या सरफेस वरती ठेवलेला आहे. हा सरफेसच्या आत का जात नाही तर सरफेस वरनं याला काहीतरी रिएक्शन मिळते. दॅट इज द मिनिंग. सो ती जी रिएक्शन या सरफेस मधनं या रोलरला मिळणार आहे वरच्या रोलरला, ती रिएक्शन ही नेहमीच्या सरफेसला परपेंडिक्युलरच असते. दिस अँगल इज ऑलवेज 90 डिग्री. ओके. मग तुम्हाला सरफेस कसाही देऊ दे, इन्क्लाइन देऊ दे, या डायरेक्शनला देऊ दे, तर ही गोष्ट नीट लक्षात ठेवा की जर दोन बॉडीज एखाद्या सरफेस वरती असतील किंवा एक सिंगल बॉडी एखाद्या सरफेस वरती असेल तर त्या सरफेस कडून त्या बॉडीवरती जी काही रिएक्शन येणार आहे ते पुश असू दे, पुल असू दे, काही असू दे, पण ती रिएक्शन नेहमी त्या सरफेसला कशी असणार आहे? परपेंडिक्युलरच असणार. ओके. सो दिस रिएक्शन is 90 degree. This reaction is at an angle of 90 degree. Okay, this is the surface. See, I will give the name. This is the surface, and this is nothing but this is the reaction. Okay, so the reaction always makes an angle of 90 degree with the surface through which it acts. Through which it acts. Okay. So now, first of all, you can see this 200 Newton force is horizontal, so there is no need to resolve it. VC is moving vertical, so there is also no need to resolve it. But this FAB, you can see over here, this is inclined force, and this may be the angle of inclination we can take. So first of all, we need to resolve this FAB to solve this problem. So to resolve this FAB force, we have to draw, we should know the angle, sorry. To know this FAB force, we should know the angle to resolve the force. So to find out the angle, if we looked in this triangle, you can look in this triangle. Okay, in this triangle, if you see, this is the vertical line. This line is the vertical line. This line is the horizontal line. So they are meeting at a point where the angle is 90 degree. This angle is 90 degree. Now here, the vertical side is 5 centimeter and the inclined side is 10 centimeter. So this is 10 centimeter and this is 5 centimeter. Now if I want to find out this angle theta, let us say that this angle is theta. Now I have to find out this angle theta. Then this is the opposite side. So I can use cos of theta. So what is the formula for cos of theta? It is opposite side divided by hypotenuse. It is opposite side divided by hypotenuse. Sorry, cos of theta is the adjacent side.
Adjacent side, sir.
Adjacent side divided by hypotenuse. It is adjacent side divided by hypotenuse. Now you can see this angle is theta. So this will become the adjacent side. So my adjacent side is 5 centimeter divided by hypotenuse. So this will become hypotenuse as it is a side opposite to 90 degree. So this will become 5 by 10, which is equal to 1 by 2. So therefore, theta is equal to, what is the answer?
60 degree.
So theta is equal to 60 degree. So this angle is 60 degree. Now we can resolve it. So now we can resolve FAB. So I will draw one component parallel to X. I will rub this 10 centimeter. So one component parallel to X, and another component parallel to Y. It will move like this because your main force should come between the two components. That is why we need to draw it like this. We will draw the force once again. So this is your force FAB, and this is the vertical component FAP. So I will write over here. If this angle theta is there, then this vertical component will become, what is this vertical component? It will become FAB
Cos 60.
cos 60, and this will become FAB sin 60. This is FAB sin 60. Okay. Now in addition to this, they have also told as weight. See here, the weight of the this circular roller is 100 Newton. So you know that weight is always acting through the center of gravity, and it is acting always vertically downwards. Weight is always acting vertically downwards. Whatever may be the body may be on inclined plane or body may be on horizontal plane. मी काय जे सांगतो ते नीट लक्षात ठेवा. The body may be resting or it is moving on horizontal plane, or a body may be resting or moving on inclined plane, which is inclined at some angle. Okay. The weight is always acting vertically downwards, and it is always acting through the CG of the body. So if I show the weight over here, so this is the weight which is acting like this from here. You can show this here also. Okay, this is the weight of 100 Newton. You can show it like this also. But here all the forces are there. So I am just for our understanding, I am shifting over here and I am showing it like this. Okay. So this is the weight of 100 Newton. So I think all the forces we have considered now. So now we will use the equations of equilibrium. Now I am going to apply summation fx is equal to 0. Okay, summation fx is equal to 0. If you apply summation fx equal to 0, then what you will get? It is 200, which is plus 200. 200 is plus, then minus FAB sine 60. Is there any other forces there? No, only two horizontal forces are there, which is equal to 0. So therefore, if you solve this, you will get the value of FAB. Let me know the answer of FAB.
Two hundred 230.94.
94.
230.94. Okay. So it is 230.94 Newton. This is the value of FAB. Now we know the force in member bar AB. Okay, force in bar AB. And we got the positive answer. Am I right? Our answer is positive. So whatever direction we have assumed, this direction, it is correct. Whatever direction we have assumed for FAB, it is correct. Now we will apply summation Fy equal to 0. So if I apply summation Fy equal to 0, then what do I get? How many forces are there? 100 is there, FAB cos 60 is there, and vertical reaction at point C, VC is there. Okay. So 100 and FAB cos 60 are plus and VC is plus and both of them are minus. So here I will write VC minus 100 minus FAB cos of 60 is equal to 0. Therefore, VC is equal to, it is 100. If I shift this 100 to that side, okay, it is 100 प्लस होणार आहे 100. त्याच्यानंतर हे FAB पण काय होईल, प्लस होईल. प्लस FAB is 230.94 cos of 60 degree. Therefore, VC is equal to
215.47.
215.47.
15.47.
Others, please do check the answer. So we got the positive answer. So our assumed direction of VC is correct. Okay. So our assumed direction of the reaction is correct. So these are the answers. Okay. So you can write at the end, the force in bar AB is 230.94 Newton and the vertical reaction at point C is 215.47 Newton. This will be your final answer. This is your final answer. Is it clear now? Have you understood the numerical? Is there any difficulty in this problem? If any difficulty is there, let me know. समजले सगळ्यांना?
Yes, sir.
ओके. तर याच्यातला की पॉइंट काय सांगितलं मी लक्षात ठेवलाय का तुम्ही, की एखाद्या वॉल मधून एखाद्या सरफेस मधून जर रिएक्शन ऍक्ट होत असेल एखाद्या बॉडीवरती, तर ती रिएक्शन जी ऍक्ट होणारी रिएक्शन आहे ही नेहमी कशी असती, परपेंडिक्युलर असते. कुणाला परपेंडिक्युलर असती, तर सरफेसला परपेंडिक्युलर असते. आणि कुठल्या सरफेसला परपेंडिक्युलर असती, तर ज्या सरफेस मधून ती रिएक्शन ऍक्ट व्हायला लागलेली आहे त्या सरफेसला ती नेहमी कशी असणार आहे, परपेंडिक्युलरच असणार आहे. ओके. So that point you should note down. Here I will tell you one more time. This is very important. See, this is the ground level or the surface. Now this roller is resting on this surface. So this roller is having some weight. Okay. So this weight is acting vertically downwards. So due to this vertically downward weight, this roller will not penetrate in the surface. Rather, it will remain as it is on the surface. What is the meaning of this? The meaning of this is somebody is balancing to this load. So some reaction is balancing this load of this circular roller. Okay. So that someone is nothing but reaction BC, vertical reaction from this surface. So if you keep the roller on the surface, this roller will not go in the surface. Okay, because this surface will give the reaction to balance the load, and that reaction which is coming from that surface, so this reaction is always perpendicular to the surface. So this is the surface to which it is always perpendicular. Okay, so this is the thing. So I hope now you understood this problem. Now I will tell you one more principle over here. At the time of solving, I will tell you. You should know this geometry theorems also. The theorems which you have studied in the geometry. That angle between the lines is angle between their tangents or angle between their normals. This theorem is required over here quite a few times to calculate the angles, to calculate the required angles. Also, you should know all the formulas of the trigonometry. That is also required. Okay, what is the formula for sine of 2 theta? What is the formula of cos of 2 theta, tan of 2 theta? Whatever required, you should know that. Okay. So now we will take the next bit, that is Lamin's theorem. So we have taken, I think, 4 or 5 numericals on this. So now I hope now you understood the concept. Apply summation fx0, apply summation fy0, and if required, then apply summation m0 and get the required forces which are asked in the numerical. So that you need to do over here in this first bit. Now the second bit is Lamin's theorem. Second is the Lamin's theorem. Lamin's theorem. What the Lamin says that when three forces are acting at a point, okay, when the three forces are acting at any point and those are in equilibrium, then if three forces are acting at a point and those are in equilibrium, then each force is proportional to the sine of angle between the other two forces. That each force is proportional to the sine of angle between the other two forces. So by taking one example, I will tell you. Suppose now this is my force F1. And this is the force F2. And this is the third force F3. I will give the name F1, F2, and F3. Now what Lamin says that if three forces are acting at any point, how many forces? Three forces. It is not valid for a single force. It is not valid for the two forces, or it is not valid for four forces also. 3 plus, if 3 plus forces are also there, then also you cannot use Lamin's theorem. You can use Lamin's theorem only for 3 number of forces. There may be the question for the MCQ also. For how many number of unknowns or under which situation you will use the Lamin's theorem. So only when there are three forces which are acting at a single point and which are in equilibrium, this condition is there, then and then only you can use the Lamin's theorem. So now if here I have drawn F1, F2, F3, three forces are there. Now we will take some angles between them. Suppose this angle is alpha. So this angle is beta. And suppose this angle is gamma. Okay. So alpha is the angle between F2, F3. Beta is the angle between F1, F3. And gamma is the angle between F1, F2. Here you can see that I am taking the angle between the forces here. I have not taken the angle with horizontal or vertical lines. Here also I can draw the horizontal or vertical lines. If I show you, see, this is the horizontal line. Okay, that is our x-axis. And here it may be y-axis. This will be the y-axis. Okay. So I have not taken any angle with x and y. You can see in the diagram. We have taken the angle which is subtended between the two forces. So what the Lamin says that whenever three forces are acting at a point and are in equilibrium, then each force, each force is proportional to the sine of angle between the other two forces. Other two, आता मी समजा F1 घेतला. F1 divided by sine of alpha must be equal to F2 divided by sine of beta, which is equal to F3 divided by sine of gamma. So this is nothing but this is the Lamin's theorem. So what Lamin says, whenever three forces are acting at a point, then each force means, suppose we take first F1 force. So each force is proportional to the sine of angle between the other two forces. मग other two forces कोण आहेत F2 and F3. त्यांच्यातला अँगल काय आहे अल्फा. त्याचं काय घ्यायचं साइन घ्यायचं. Okay. So sine of that angle, sine derivative of that angle we should take. So this proportion must be equal to the F2 divided by sine beta, which must be equal to F3 divided by sine gamma. So this is the Lamin's theorem. This is called as the Lamin's theorem. So now if I write the statement of the Lamin's theorem, then the statement will be if three forces if three forces are acting at a point are in equilibrium then each force is proportional to the sine of angle between the other two forces. This is the Lamin's theorem. So if three forces are acting at a point are in equilibrium, then each force is proportional to the sine of angle between the other two forces. So here also you can see F1 upon sine of angle between other two forces, F2 and F3 madla angle hai alpha. So that angle we are taking. So these alpha, beta and gamma are the angles between the forces. These are the angles subtended between the forces which are acting at the point. Alpha, beta and gamma are not the angles with horizontal or vertical. These are not the angles with x-axis or y-axis. Okay, you have to remember this point. So if it is over, whatever written on the board, then we will move to the next slide. So we will see the proof of this in short. Actually, the proof is not there for your syllabus. Still, I will tell you. Is it over? झालंय का लिहून? Yes, no, काय?
Yes, sir.
Yes, sir.
Okay. So now to prove the Lamin's theorem, I will consider these three forces which are acting on the three sides of a triangle. Okay, normal triangle we will take, and we will consider these three forces are acting on the three sides of the triangle. So here I will draw the three sides of the triangle. This proof is not there for your syllabus, by the way. I am just telling you how it is calculated. So that is why I am taking. Actually, it is out of the syllabus for you. Derivation will not be asked in the examination. Just tell you the formula, I am doing this. So now let us say that this is force F1, this is F2, this is force F3, then here is the angle, this angle, exterior angle is alpha, then this exterior angle is beta, and this exterior angle on this side it is gamma. So here I will give the names also. Names are A, B, and C. Here I will write three forces F1, F2, and F3 are represented by the sides of triangle with exterior angles with exterior angles alpha, beta, and gamma respectively. Whatever we have shown, that is given in descriptive manner. So three forces F1, F2, and F3 are shown on the three sides of the triangle, and the exterior angle of the triangle is alpha, beta, and gamma respectively. Okay. Now apply the sine rule. So apply sine rule in triangle ABC. Now you must know what is sine rule. Okay. Now if you apply the sine rule, then it will be, now first side is this AB. So AB upon sine of 180 minus alpha, which is equal to BC upon sine of BC is equal to sine of 180 minus beta, which is equal to what side we have taken? AB. For AB, this angle. For BC, it is gamma. For AC, it is beta. So here I have written beta. So I will write AC. This AC side opposite चा exterior angle घ्यायचा असतो. Side च्या opposite चा angle घ्यायचा कधी पण. मी असं अज्युम करून चाललोय की साइन रूल तुम्हाला माहिती आहे, कारण तुम्ही शिकलाय ट्रिग्नोमेट्री मध्ये. नेक्स्ट इज BC. BC डिवायडेड बाय ह्याच्या अपोजिट अँगल इथला एक्सटेरियर अँगल. साइन ऑफ 180 minus gamma. So it is AB divided by, you know the formula, but sine 180 minus alpha is equal to what? It is sine alpha. It is sine alpha. So therefore, it is AB. AB means what? F1. AB means what? It is F1. It is F1 divided by sine of 180 minus alpha means sine alpha.